Hello everyone. My name is Manya, and we'll be starting our AMC-8 training for 2019 problems. I'll share my screen. We can be starting our AMC-8 2019 problems and solutions. So our agenda is that we'll be doing the AMC 2019 problems, and we'll be talking about strategies and tips to improve your score on the AMC 8. And then there'll also be a question answering session where you can ask some questions at the end, and I'll be answering them. And let's get started. Problem number 1. Ike and Mike go into a sandwich shop with a total of $30 to spend. Sandwiches cost $4.5 each, and soft drinks cost about $1 each. Ike and Mike plan to buy as many sandwiches as they can, and they use the remaining money to buy soft drinks. Counting both the sandwiches and soft drinks, how many items will they buy? So, to calculate how many items they'll buy, we know that the top priority for them is that they want sandwiches. And so if they want sandwiches, their top priority is sandwiches. So we need to know how many sandwiches can they buy? The highest number. So we can try 4.5 times 7. And 4.5 times 7 is equal to 31.5, which is greater than $30 because they have a total of $30. So then we can do 4.5 times 6. And 4.5 times 6 is equal to 27. And 27 is less than 30. And so the largest number of sandwiches they can buy is 6. And then with the remaining money, so we can do 30 minus 27 to find out how much money they'll have left over. So 30 minus 27 is equal to 3. And so that means that with the $3, they need to buy as many soft drinks as possible. And so, since we know that the soft drinks cost $1 each, we can do 3 divided by 1, which is equal to 3. So in total, they can buy a total of 6 sandwiches plus 3 soft drinks, and 6 plus 3 is equal to 9. And that's how we got our answer choice D. Problem number 2. 3 identical rectangles are put together to form a rectangle ABCD, as shown in the figure below. Given that the length of the shorter side of each of the smaller rectangles is 5 feet, what is the area in square feet of rectangle ABCD? So they need us to find the total area of ABCD. So what's the area of this whole rectangle? Well, first to find out the area, we know that the length of each of the shorter side of the smaller rectangles is 5 feet. So then that means that this is 5 feet. This is 5 feet. This would be 5 feet. And this would be 5 feet. This would be 5 feet. This would be 5 feet as well. And so to find the total length of AD, then we would have to do 5 plus 5, which is equal to 10. So AD is equal to 10. That also means that CB is also equal to 10. What is the length of AB? Well, to find out the length of AB, we know that suppose that this point can be E. This point is E. So then from EB, it's gonna be 5. What's AE? So to find out the length of AE, well, since we know that this side is equal to 10, AD is equal to 10, and we know that AD is equal to AE, and suppose this can be F. So we also know that FE is equal to 10, since CB will be equal to 10 as well. 5 plus 5 is equal to 10. So to find out the length of AE and DF, it would still be equal to 10 because it's a square. So then this would be equal to 10, and this would be also equal to 10. What's the total length of AB? Well, the total length of AB would be equal to AE plus EB, which is equal to 10 plus 5, which is equal to 15. And so we figured out the length of AD and AB. And so since we know that the area is equal to base times height, which is also length times width, L times W, we can do area equals 10 times 15. And if we solve area equals 10 times 15, which is equal to 150. That's how we got our answer choice E. Problem number 3. Which of the following is in the correct order of the fractions? 15 over 11, 19 over 15, and 17 over 13 from least to greatest. So they want us to arrange this from least to greatest. So what many people would like to do is just probably draw a circle and then split it into 11 parts and then color or make two circles and then split each of them into 11 equal parts and then shade 11 of them, so shade this whole entire circle and then shade four of these. But that's not very efficient. Drawing circles for shading parts is not very efficient because so if we want to split it, it won't be exactly. So some people would like to draw a rectangle and then split it. A rectangle is more efficient than a circle. So we can draw two rectangles and then shade 11. So shade a whole rectangle and then shade four parts of this. But that is also not very efficient because it'll be very time consuming and you will not have that much time to do this. So then, since we know that the smaller the denominator is, this is the denominator and this is the numerator. So I'm going to write D for denominator. Denominator is just the bottom number, and the numerator is just the top number of a fraction. So the smaller the denominator is, the larger the pieces will be. So suppose that we have 1 by 2. So 1 out of the 2 pieces. We have 2 pieces here, and then we're going to like shade 1 out of the 2 pieces. So it's 1/2. And then to compare, we have another rectangle, and it's 1/4. So this means that we would have to split the rectangle into 4 parts and then shade one of them. Is this part bigger or is this part bigger? Well, I'm pretty sure that this part is bigger than this part. And so that means that the smaller the denominator is, the larger the pieces will be. This just proved why. And so what is the smallest denominator here? It's 11, and then 13, and then 15. So, and plus 11 plus 4 is equal to 15. 15 plus 4 is equal to 19. 13 plus 4 is equal to 17. So if we add, so D plus 4 is equal to N. Denominator plus 4 is equal to the numerator in this case. So how would we arrange these in least to greatest? We know that 15 over 11 is the greatest because once again, the smaller the denominator is, the larger the pieces will be. So that is the greatest. So I'm gonna we need to arrange this from least to greatest. So 19 over 15 will be the least, and then 17 over 13 will be the middle one, and then 15 over 13 will be the greatest. And so that's from least to greatest. So then it's 19 over 15, and then 17 over 13, and then 15 over 11. So now we need to find the answer choices. The largest number will be over here. So the largest number is 15 over 11. So this one's wrong, this one's wrong, this one's wrong. So it's either C or E. 17 over 13 will be the middle number, so it's E, so it cannot be C. And then 19 over 15 will be the one on the left side. So 19 over 15 is is smaller than 17 over 13, which is smaller than 15 over 11. And that's how we got our answer choice E. Problem number 4. Quadrilateral ABCD is a rhombus with a perimeter of 52 meters. The length of diagonal AC is 24. What is the area in square meters of the rhombus ABCD? So, we know that AC is equal to 24. And to find out AB, BC, CD, and DA, we'll have to do 52 divided by the total number of sides. And the total number of sides in a rhombus is 4. So 52 divided by 4 is equal to 13. So 13 is the total measurement of AB, BC, CD, and DA. So now, since we know the measurement of the sides of the outer sides, we need to know what is the measurement of BD. So to find out the measurement of BD, well, if we look closely, there will be a right angle here, right angle here, right angle here, and a right angle here, and a right angle there. So this means that this will be a right angle. And to find out the area of the right angle, it's a squared plus b squared equals c squared. A, b, c are just variables. So then we can find out so the middle point can be 0.8. We'll do the middle point as 0.8, where both of AC and BD intersect, right there. That's 0.8. So we know that AB is equal to 13. So 13 squared, C squared is equal to 13 squared. And we know that AC is equal to 24. So then half of AC is equal to AE. AE is equal to 24 divided by 2, which is equal to 12. So then A squared plus 12 squared is equal to 13 squared. And so I'll just write A squared plus 144, which is 12 squared, is equal to 169. And 169 is 13 squared. And so if we subtract this, 169 minus 144, we're going to get A squared is equal to 25. And we need to find the square root of 25. If we find the square root of 25, it's going to be A equals 5. And remember that A represents BE in this case. So then, to find the total length of BD, we'll have to do 2 times BE. And 2 times 5 is equal to 10. So then the total length of BD is equal to 10. So BD is equal to 10. And the area of a rhombus is area equals base times height by 2. And base times height and length times width are basically the same thing. So area equals base times height by 2. So it's going to be equal to 24 times 10 by 2. And then we can divide by 2. Yeah. So cross out the 2, cross out the 2. And then it's going to be equal to 12 times 10 over 1. And 12 times 10 is equal to 120. And that's how we got our answer choice D. Problem number 5. A tortoise challenges a hare to race. The hare eagerly agrees and quickly runs ahead, leaving the slow-moving tortoise behind. Confident that he will win, the hare stops to take a nap. Meanwhile, the tortoise walks at a slow, steady pace for the entire race. The hare awakes and runs to the finish line, only to find the tortoise already there. Which of the following graphs matches the description of the race, showing the distance D traveled by two animals over T from start to finish? So we know that the tortoise and the hare are racing, but the tortoise finishes before the hare. It's just like the story of the tortoise and the hare. So the tortoise reaches before the hare. And so the tortoise keeps going in like a straight line. Just keeps going in a straight line. And the tortoise does not take a break. Meanwhile, the hare takes a break. So the hare stops for a little bit. So we know that the tortoise will reach before the hare. And so the one in like the straight line, there's 2 lines here. In every single graph, there's 2 lines. The one that has a straight line has to finish before. So this is the amount of time. So this is the graph. This is the time. So then it's going to be 1, 2, 3, 4, 5. And then the distance will be equal to like 1, 2, 3, and something like this. And so if we go like this, and then they reach 3, so suppose that the total distance is 3 miles. If they reach 3 miles in suppose 3.5 hours, or maybe like 4 hours. Okay, and then someone else's, maybe the rabbit may reach like maybe the rabbit or like the hare may reach maybe the hare may reach like this, and then like it may take a break, and then it can keep going like that. Or it should be looking something like this. Okay? So this is just an example, and the tortoise will reach before because it takes less time. And so in graph A, we know that the one in traveling a straight line will reach after the hare. And so A cannot be correct because a straight line has to reach before the the um the line that is not straight. And so B, the tortoise reaches before the hare. So B can be the answer. C can also, D can, and E can. Once again, it's because in a straight line, the tortoise reaches before the hare. So when the rabbit or when the hare takes a break, the hare cannot go backward because when you take a break, you just stop. You cannot go forward, neither can you go backward. So when the hare takes a break, it must be a straight line. And so B can be the answer. So I'm gonna put a question mark here. C cannot be answered because the hair is going downward, means that it is being a bit means that it is going backward. And so C cannot be the answer. Oh yeah, D cannot be the answer either because when we were talking about the hair, when we were talking about the tortoise being in a straight line, in this graph, it shows that the tortoise also took a break, and so D cannot be the answer. E cannot be the answer either, because when the rabbit or when the hare is taking a break, the hare is going upward. The line is going upward, means that the rabbit is moving. And so E cannot be the answer either. So then the only answer that can actually work is answer choice B. And that's how we got our answer. Problem number 6. The 81 grids uniformly spaced in the square shown in the diagram below, including the points on the edges. Point P is the center of the square. Given that point Q is randomly chosen among the other 80 points, what is the probability that the line PQ is a line of symmetry for the square? So I'll be changing my color to blue. And in this grid, this uniformly spaced means that they're equally spaced throughout. And so what is a possible line of symmetry? So we can do it in the edges. Oh, I'll change it. Yeah. So there's a point for the edges where there can be a line of symmetry here. And so first of all, we'll just start by drawing a square. So or yeah, so I'll draw a square here. This looks something like a square. And so the line of symmetry that's possible is this part, this one here, and this one here. This is not a perfect square, but yeah. So these are the line of symmetries that are possible for a square. And so we can do the same thing here. So we can just circle the possibilities here. So here, here, and here. And so now these are the possibilities, and we can just keep going until the midpoint. So I'm gonna just keep like circling the dots that are possible here. And so this is what we have so far. It's this one here. This is see this line here? And we're not shading the point P because we're not shading that because point Q and point P cannot be the same one. Since we're trying to find out the line of symmetry, point P cannot be equal to point Q. They both cannot be the midpoint. And so these are the possibilities for the line of symmetries. And if we count all of these points of 1, 2, 3, 4, 4 times 8, which is equal to 32. So there's 32 total blue circles here. And then there's going to be 81 minus 1, since point Q cannot be the center point of point P. So 81 minus 1 is equal to 80. So 80 total possibilities. So 32 divided by 80 is equal to 32 is equal to 4 by 10, which is equal to 2 by 5. And that's how we got our answer choice C. Problem number 7. Shania takes 5 tests, each worth a maximum of 100 points. Her scores in the first 3 tests were 76, 94, and 84. In order to average 81 for all of her 5 tests, what is the lowest score she can possibly earn on one of the other 2 tests? So we know that they want the average to be equal to 81 for all of the 5 tests. So if they want it to be 81, and to find out the total, we can do 81 times 5, which is equal to 405. And so now we can add all of these up. So we know that they want the total to be 405. So 76 plus 94 is equal to 170. 170 plus 87 is equal to 256. So 76 plus 94 plus 87, sorry, it's equal to 257. And so it's equal to 257. So we can do 405 minus 257. And if we would subtract them, we would be getting 148. And so we need 148 for the last 2 tests. Suppose that she earns 100 on one of her tests, because it says maximum score of 100 points. So 148 minus 100 is equal to 48. And we did minus 100 because we're trying to find the lowest possible score. And the lowest possible score she can earn on one of her tests to average 81 for all 5 tests is A, 48. Problem number 8. Gilda has a bag of marbles. She gives 20% of them to her friend Pedro. Then Gilda gives 10% of what is left to her other friend Ebony. Finally, Gilda gives 25% of what is left in the bag to her brother Jimmy. What percent of the original bag of marbles does Gilda have left for herself? So she starts off, suppose that she has, we'll do 100 bags. 100 marbles. It's just like, suppose that can be like 100% or 100 marbles, or it can be anything. Okay, so suppose that she has 100. She gives 20 of them to her friend Pedro. So 20% of 100, so 20% of them is equal to 20. And then we can do 100 minus 20, since we know that 20% of 100 is equal to 20, equals 80. And so, here, I'll just write that there. And then she gives 10% of what is left to her friend Ebony. So 10% of 80 is equal to 8. And so she gives 10% of that. So then we would do 80 minus 8, which is equal to 72. So she still has 72 left. And then she gives 25% of what is left in the bag. So 72 are left, and then she gives 25 of that to her brother Jimmy. So 25% of 72 is equal to 18. And so we would have to do 72 minus 18, which is equal to 54. And that's how we got our answer choice E, 54. And also, they're just asking for the percent, so we can, so 54 is equal to 54% in this case. So she still has 54% left. And yeah, that's how we got our answer E. Problem number 9. Alex and Felicia have cats as pets. Alex buys cat food in cylindrical cans that are each 6 centimeters in diameter and 12 centimeters high. Felicia buys cat food in cylindrical cans that are 12 centimeters in diameter and 6 centimeters high. What is the ratio of the volume of one of Alex's cans to the volume one of Felicia's cans? So we know that we can do A for Alex and F for Felicia. So A is equal to 6 centimeters in diameter, and then she has 12 centimeters high. So then we can do 12H. Felicia, on the other hand, has 12 centimeters in diameter, so 12D, and 6 centimeters high. And so to find the area of a cylinder, so area is equal to, well, in a circle there's or sorry, in a cylinder there's a circle. And so area is equal to, so area is equal to pi, so pi r squared, which is the area of the circle, times the height. So pi r squared h. So area, so then we can substitute the values of this. So then for Alex, it's gonna be equal to area, so it's gonna be so we know that 6 is the diameter, and so what is the radius? So the radius would be half of the diameter, which is 3. So pi times 3, so 3 square times the height, which is equal to 12. And then divided by, since they're asking for the ratio of Alex's can to Felicia's cans, we would have to do pi pi times half of the diameter, which is the radius, so it's going to be 6 squared times the height, which is also equal to 6. The pi and pi cancel out, and we're going to be getting 3 3 times 3 times 12 by 6 times 6 times 6. And so we can just cross these off. 1, 1, so 1 here, and then 2, 2. I'm just crossing off these, and then that's going to be 2 and 1. And so if we would write this on the bottom, we would be getting 2 times 2 over 2 times 2, which is equal to 4. And so 2 over 4 is equal to 1 over 2. And so the ratio would be equal to 1 over 2. 1 to 2. And that's how we got our answer choice B. Does anyone have any questions on this problem? Problem number 10. The diagram shows the number of students at soccer practice each weekday during last week. After computing the mean and the median values, coach discovers that there were actually 21 participants on Wednesday. Which of the following statements describes the change in the mean and the median after the correction is made? So what's the mean and what's the median? So the mean would be the average. So I wrote average here. And the median would be the middle number. So in this graph, they showed us a total, or in here, they told us that the number of students who participated. So on Monday, it's going to be 20. On Tuesday, it's going to be 26. Wednesday, 16. Thursday, 22. And Friday, 16. So I'll just write this here. So Monday is equal to 20. Tuesday is equal to 26. Wednesday is equal to 16. And we'll do the new values later when the coach discovers that there's actually 21 participants on Wednesday. We'll do that later though. And then Thursday is equal to 22. Friday is equal to 16. And so to find the mean, we can just calculate all of this and divide it by 5. And so when we calculate it, we're going to get 46 plus 16 is equal to 62, 46, and then 62. We'll be getting 100. So if we do 100 by 5, we do by 5 once again because we're trying to find the average. And so we add all of these up and then we divide it by 5. So 100 by 5 is equal to 20. And so that means that the mean is equal to 20. To find out the median, we need to arrange these in least to greatest values. So it's going to be equal to 16, 16, 20, 22, and 26. And we can start off by crossing out the left side and the right side. And then we'll be left with the number 20 right in the middle. And so we know that the mean and the median are both equal to 20. They both are equal to 20 in this case. But this is always not true. The mean and the median, most of the time will not be equal to the same number, but in this case it is. And that really just depends for the numbers. So we can add the 21. So we can add 5 more participants. And it should actually be looking something like this, but the coach made a mistake. So then, yeah, it should be looking something like that. And so since we know that there's 5 more participants, we can just add 5 to the mean. Since we already know that everything is the same except for just 5 more participants. And so I'll be using the color blue to show the new values. And so 100 plus 5, which is equal to 105, by 5, since we just do by 5 since there's no more like new weekdays added to the calendar or something. So then 105 by 5 is equal to 21. And so that means that the mean added 1. So 21 plus 20 plus 1 is equal to 21. And so the mean increases by 1. And so eliminating the answer choices, it cannot be D and it cannot be E either. Since it says the mean increases by 5, but actually the mean only increases by 1. So to calculate the median, we would have to once again arrange these in least to greatest order. And so the numbers are 16, 20, 21, 22, and 26. And so if we cross all of these off, if we cross these numbers off from once again left to right, we'll be left with the number 21. And so both the mean and the median are 21 in this case. And so that's how, and so the mean and the median both increase by 1. The mean increases by 1 and the median increases by 1 as well. And so A cannot be the answer because the median does change, and C cannot be the answer either because the median does not increase by 5. And B is the answer. The mean increases by 1 and the median also increases by 1. And that's how we got our answer choice B. Problem number 11. The third grade class at Lincoln Elementary School has 93 students. Each student takes a math class or a foreign language class. There are 70 third graders taking a math class, and there's 53 third graders taking a foreign language class. How many third graders take only a math class and not a foreign language class? So, the third graders have 93 students. And each student takes a math class or a foreign language class or both. And so we know that there's 70 taking a math class and 54 taking a foreign language class. And we can add both of them up together. So 70 plus 54 is equal to 124. That is the total number of students, or not the students, the total number of classes the third grader take in total. So 124. And so 124 minus 93, and we do this to find out the students that are taking both of the classes. And that will be equal to 31. And so how many students only take a math class and not a foreign language class? Since this is both, we'll have to do 70, which is the total number of students taking a math class, minus the students that are taking both of the classes. So 70 minus 31 is equal to 39. So 39 is the total number of third graders that only take a math class and not a foreign language class. And that's how we got our answer choice D. Problem number 12. The faces of a cube are painted in 6 different colors. Red, R, white, W, green, G, brown, B, aqua, A, and purple, P. 3 views of the cubes are shown below. What is the color of the face opposite to the aqua face? And so they're showing 3 different rotations of the cube that they do. So, first of all, this is the first rotation. And so when they turn the cube sideways, they turn it counterclockwise. This when they turn it counterclockwise, if they turn it, then the red will be moving over here. And then the green will disappear since the green is on the back side. And so the side that is opposite to the green is actually W. Since when we rotate it, the green will go over here. So green is actually over there and W comes in here. And so when we do this rotation, W is over there. So yeah, so then W, the opposite side to W is equal to green. And so in this rotation, the next rotation, we'll use this one. And so they turn the cube this way. They turn it around. So then the red will be moving up here. And so the green will be turning sideways and the B will be the B. So B will be moving backwards. So the B will be like all the way back there in this rotation. Or I'll write it right here. So the B will be over there. And so that means that the P in this one is on the bottom. Since when we turn it sideways, the P is on the bottom and the B is on the back side. So then that means that P is equal to B. Or not equal to, it's on the opposite side. And so that means that if W is equal to G, or sorry, not equal to, it's on the opposite side of G, and P is on the opposite side of B, then what is opposite of A? Well, since a cube has 6 faces, red is the only one that is not in here. So then that means that the face that is opposite to the aqua face is the red face. And that's how we got our answer choice A. Does anyone have any questions on this problem? Problem number 13. A palindrome is a number that has the same value when read from left to right or from right to left. For example, 1, 2, 3, 2, 1 is a palindrome. Let n be the least 3-digit integer, which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? So then, so we know that a palindrome is the same number from left to right. So then a 2-digit palindrome, they're asked for a 2-digit palindrome. So 2-digit palindrome must be a multiple of 11. So think of a not multiple of 11. So think of maybe 12. Is 12 a palindrome? Well, 12 is not a palindrome since 12 does not equal 21. We'll think of maybe 11. Is 11 a palindrome? Yes, because when you write it from left to right or right to left, it is always the same. So 11 equals 11, so that is a palindrome. Now another example, we'll think of like maybe 22. 22 is a multiple of 11. Therefore, when read from left to right or from right to left, 22 is equal to 22. And so we just proved that a 2-digit palindrome or 2-digit multiples of 11 are palindromes. And a 2-digit palindrome must be a multiple of 11. And so they want the least 3-digit integer, which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. So we'll add up 11, 22, and 33. These are the smallest numbers. So 11 plus 22 is equal to 33. 33 plus 33 is equal to 66. And so 66 is still not a three-digit palindrome. And so we'll think of maybe 11 plus, we'll do maybe 33 plus 66. And if we add all these together, 11 plus 33 is equal to 44. 44 plus 66 is equal to 110. And so this is a three-digit number. And we can think of, well, we'll find the largest number. So 77, 88, and 99. This will easily be a three-digit palindrome, but it's probably not going to be the smallest one. And so once again, they want like the smallest palindrome, so they want the smallest one. And so another one can be maybe 22, 22, 33, and 55. And so if we add all these up, so 22 plus 33 is equal to 55, and 55 plus 55 is equal to 110. And so a three-digit integer, and it's not a palindrome either. And so this is the smallest three-digit number, which is the sum of three-digit integer, three distinct integer, and be the least three-digit integer, which is not a palindrome, but it's the sum of three distinct two-digit palindromes. Also, the word distinct means that they want like three different two-digit palindromes. So they don't want every single number to be the same. And so if we add up the digits of n is just this number right here, n is 110. So 1 plus 0 is equal to 2 plus 0, which is equal to 2. And that's how we got our answer choice A. Does anyone have any questions on this problem? Problem number 14. Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she will redeem one every 10 days until she used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realizes that no circle date falls on a Sunday. On what day of the week does Isabella redeem on her first coupon? So first we'll make a chart. So as for Sunday, and then Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, so we can do this. And so suppose that she can't start on a Sunday because that's the one day that they don't want to redeem on. And they want 6 coupons, so they want to circle 6 dates, and none of them should be falling on a Sunday. So Monday can be number 1. The first one that she can redeem is Monday. So then Tuesday, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Wednesday will be the second day, the second time. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. Or wait, suppose that we can start with, we'll do like, we'll start with Wednesday. Since it can be like the middle of the week, or we can start with Wednesday. And then it can be 1, 2, so this is the first day. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be a Monday. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or it's gonna, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since that or yeah, so we can start by doing, since we know that, sorry, let me explain this problem once again. So suppose that she starts redeeming on Monday. So Monday can be number one. Monday is the one day that she can redeem on. And so she will redeem once in every 10 days. So so this is the first day that she'll redeem. And then the next day she'll start again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if she starts on a Monday, then she will automatically redeem on a Sunday, the third week. So then that means that she cannot start on a Monday. So she'll start on a Tuesday. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so once again, if she starts on a Tuesday, then she will automatically redeem on a Sunday. So she cannot start on Tuesday. So she'll start on a Wednesday. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can stop at 6 since she only has 6 coupons. And when we do Wednesday, none of the dates will be following on a Sunday. And so that means that the first day that she will start on is C, Wednesday. So one of the questions and someone asked is that there might be a better solution for this, but then there can so to find out a better solution, since we know that we need to draw a chart, a calendar, so we can start by like making a calendar here, or instead of doing all of the dates, just make a chart, something like this, and so you can try out each one that is possible. And I don't think there's an easier solution that I know of, but there might be a better solution. And I can tell you that if there's any better solution on this. Yeah, so I can tell you maybe the better solution of this maybe in the next class, or which is tomorrow. Problem number 15. On a beach, 50 people are wearing sunglasses and 35 people are wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, what is the probability that this person is also wearing sunglasses? That this person is also wearing sunglasses is 2/5. If instead someone is wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? So there's 50 people in total that are wearing sunglasses and 35 people that are wearing caps. And so they want that, so if someone wearing a sunglasses is selected at random, what is the probability that this person is also wearing a cap? And so there's 2 by 5 people that are wearing that, 2 by 5 people that are, the probability that they're also wearing sunglasses. So if someone's wearing a cap, the probability that that person is also wearing sunglasses is 2/5. And so since there's 35 people that are wearing caps, we'll have to do 2/5 times 35. Since they're asking someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? So 2 over 5 times 35. So if we would solve this, then we will be getting 2 times 7, which is equal to 14. So 14, so 14, so 14 over 50, so 50 is the total number of people who are wearing sunglasses. So 14 is the number that people are wearing caps. And so so caps over the number of sunglasses. So 14 over 50 is equal to 7 over 25. And that's how we got our answer choice B. Does anyone have any questions on this problem? If so, you can raise your hand or you can unmute and ask. Okay, if no one has any questions, then we'll have a 2-minute break. And yeah, we can be starting at 10:55 PST. So break is over now since it's 10:55 PST. And we can get started with problem number 16. We just finished problem number 15 and all of the problems before that, and we can start with problem number 16. So Quang drives 15 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? So, this person can drives 15 miles at an average speed of 30 miles per hour. So 15 over 30. And then he will have to drive 55 miles per hour to average 50 miles per the entire trip. And so then we can do and so now we can do so the only multiple of 55 in the answer choices is equal to 110. So that would be our answer. But let's not depend on the answer choices and let's just try to solve this on our own. We automatically know that a D is our answer because once again, 110 is the only multiple of 55 in this case. But let's not depend on the answer choices. And so now we can do 110. We can do 55 times 2, which is equal to 110 by 55. And so if we solve this, we will get 2.5, which is equal to 5 by 2. So 5 by 2 is equal to, well, what's 15 plus 110? 15 plus 110 is equal to 125 over 55. And this will make sense. So 125 over 55. And so that also proves why D is our answer choice. But let me take a different example. Suppose instead of 110, we have 55. So just 55 times 1. So 55 times 1. So that will be equal to 1.5. And so 1.5. So 1 point, so instead of 110, we'll do 55. So that will be equal to 1.5 instead of 2.5. And then 1.5. So 3 by 2 is equal to 55 plus 15, which is equal to 70. So 70 by 55. Is 3 by 2 equal to 70 over 55? No, it's not equal to 70 over 55. And so this cannot be our answer. And so this proves why that why 110 is the number of additional miles you will have to drive to average 50 miles for the entire trip. And that's how we got our answer choice D.
But 125 divided by 55 isn't 5 2.
Oh, sorry, this is 125 by 50. Since there's 50 miles, 50 per average, it says 50, so it says how many additional miles does he have to drive to average 55 miles per hour to average 50 miles for the entire trip. So sorry, this is actually 50, not 55. Problem number 17. What is the value of this product? So they gave us all of this, but we don't need to we don't need to solve all of this. We need to find a more efficient way to solve this. So we can start off by canceling these out since multiplication and division both cancel out. So we can do this. Just cancel out the 3, 3, 4, 4. And then we can cancel the 99, 98. And we will know that the 5 and 4 will be canceling in the next sequence, and 97 and 98 will be canceling on the before sequence. So the three dots means that it'll be continuing the sequence. And so we'll be left with 1 over 2 times 100 over 99. So 1 by 2. So 1 by 2 times 100 by 99. And so we would be getting 100 by 2 times 99 is equal to 198. And so 100 over 198, if we divide by 2 on both sides, then we'll be getting 50 over 99. And that's how we got our answer choice B. That is the total value of this product instead of solving all of this. If you would want, you can solve all of this and you would still get the same exact answer. Problem number 18. The faces of each of the two fair dice are numbered 1, 2, 3, 5, 7, and 8. When the two dice are tossed, what is the probability that their sum will be an even number? So, so in this case, there's two even numbers. So two even numbers and four odd numbers. So then there can only be an even number if there can be four odd. So if there can be either two odd and two even. So then we would be getting, since there's four odd numbers and four even numbers, or sorry, four odd numbers and two even numbers, we'll have to do four odd numbers times the four odd numbers as well because they want the two dice. Two of the dice are tossed. So 4 over 6 times 4 over 6 is equal to 16 over 36. So 16 over 36. And then we have to do the even numbers again. So it's going to be equal to 2 over 6 times 2 over 6. And then just multiply the numerators and then multiply the denominators, and we'll be getting 4 over 6. And so we can just add these both up. Since they're asking what is the probability that their sum will be an even number. This is the probability. So 16 over 36 plus 20 plus 4 over 6, 36. And then if we add both of these up, we'll be getting 20 over 36. And so if we would reduce this, we will be getting divide by 4, so 5 over 9. And that's how we got our answer choice C. Does anyone have any questions on this problem? Problem number 19. In a tournament, there are 6 teams that play each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. After all of the games have been played, it turns out that the top 3 teams earn the same number of total points. What is the greatest possible number of the total points for each of the top 3 teams? So there's top 3 teams, and there are 6 teams that play. So suppose that the top 3 teams are A, B, and C. And the bottom 3 teams, or the lower 3 teams, are D, E, and F. So suppose that A can play with D, A can play with E, A can play with F. The same thing applies to B. B plays with D, B plays with E, B plays with F. C plays with D, C plays with E, and C plays with F. And they play each other. So suppose that A wins all of the 3 games. So A wins 3 games, so 3 times, and they play each other twice, since they say that they play each other twice. And A earns 3 points for a win. So once again, A wins all 3 games, and A plays them twice. So they play each of the teams. So they win all 3 games. They play twice, and the team A wins 3 points. So the total number of points A would win is 3 times 2 times 3, which is equal to 6 times 3, which is equal to 18. So A would win 18 points. And so now A would play with B, A would play with C, and B would play with C as well. And so since we know that the top 3 teams earned the same number of total points, assuming that B won with D, E, F, and C won with D, E, F as well. So A has 18, B has 18, and C has 18 as well. Now, since the total number of points has to be equal, what is the greatest number of total points for each of the top 3 teams? So A has to win with B once, B has to win with A once, A has to win with C once, C has to win with A once, B has to win with C once, and C has to win with B once. And so that means that A will win 6 points, B will win 6 points, and C will win 6 points as well. Here, let me draw this right here. A, B, and C. So they do this twice, so that A, B, C, this is just a duplicate of the same exact thing. So A, B, C. So suppose that B wins, and then C wins, and then A wins with C. The same thing applies here. So now A wins with B, B wins with C, and C wins with A. And so how many points does A win? 3 plus 3, which is equal to 6. B wins 3 plus 3, which is also equal to 6. And C also wins 3 plus 3, which is also equal to 6. And so we'll have to do 18 plus 6, which is equal to 24. And once again, we do 6 because it turns out that the top 3 teams earn the same number of total points. And so what is the greatest number of total points for each of the top 3 teams? They're not asking us to do 24 times 3. They're just asking us how many points does each of the top 3 teams win. And that's how we got our answer C, 24. Problem number 20. How many different real numbers x how many different real numbers x satisfy the equation? X squared minus 5 in parentheses squared equals 16. So now we can do that x squared minus 5. We can find out the square root of 16 since there's a square root symbol here. That means that the total of the parentheses squared. X squared minus 5 is equal to the square root of 16, which is equal to 4. Add 5 on both sides. So x squared is equal to 4 plus 5, which is equal to 9. And so x can be equal to 3, and x can be equal to negative 3. So there's two possible solutions for this one. But now we can also do x squared can be equal minus 5 can be equal to negative 4 as well, since negative 4 times negative 4 is equal to 16. Negative times negative is equal to positive, so then this can work as well. And so we can add 5 on both sides, so x squared negative 4 plus 5 is equal to 1. So x squared is equal to 1, x is equal to 1, and x can also be equal to negative 1. So there's 4 possible solutions for this equation. X equals 3, x equals negative 3, x equals 1, and x equals negative 1. And so that's how we got our answer choice D. There's 4 possible solutions for this equation. Problem number 21. What is the area of the triangle formed by the lines y equals 5, y equals 1 plus x, and y equals 1 minus x? For us to find out the area of this triangle, we'll have to know the coordinates on the graph so that we can graph this triangle. Or I'll teach you a simpler way to solve this problem. So y equals 5, and we can substitute the value for y, and we can find out x. So 5 equals 1 plus x. 4 equals x minus 1, so 4 equals x. Therefore, our first coordinate will be equal to 4, 5. Our next coordinate, well, let me just put this right here. I'll draw the triangle. So this can be the triangle that we can use here. Okay, so this can be our coordinate here. And now we can find the other coordinate. So we can do once again y equals 5, 5 equals, and we can substitute the value for this one. So y equals 1 minus x. So then 4 equals negative x. So then that will be equal to times negative 1 times negative 1, so it will be equal to negative 4 is equal to x. So then our next coordinate will be equal to negative 4, 5. Negative 4, 5. That's our next coordinate. Now for our final coordinate, we know that it will be equal to. So suppose we can do this. So 1 plus x is equal to 1 minus x. And we do that to find out the value of x here. And so x equals negative x. Is this really possible? In fact, it is possible, but there's only one solution to this. X has to be equal to 0 because 0 is neither positive nor negative. So, in this case, if x is equal to 0, what's y? So, y is equal to 1 plus 0, so y is equal to 1. Once again, y is equal to 1 minus 0, so y is equal to 1. So the coordinates are 0, comma, 1. So these are the three coordinates that we have. So it's 0, comma, 1. It is 4, comma, 5. And it is a negative 4, comma, 5. And now, so we can do y, sorry, this is x. x1, y1, x2, y2, and this can be x3, y3. So this is y3. So see this formula down here. This is called the shoelace theorem, which states that this is a really hard way to do this. And I think that this is not very efficient because this is the total formula. You'll have to substitute all of these values and it's gonna take up a lot of time. Uh, I don't I don't want to use this formula to solve this problem, but you can also substitute the values. So x1 is right here. x1 plus y2, so times y2. You can like solve this, but it's not going to be very efficient and very time consuming. And one thing that I would like to tell you about this is that there's an absolute value sign here, which means that this will always be positive, since absolute value is the distance from 0, which means that it'll be positive. Then we'll have to divide by 2, since that's the area of a triangle, of this kind of triangle. And so instead of using that, you could use that, but I don't really like using that one. So I'm just gonna leave this formula if you would like to use this. So instead of doing that, I found out an easier way to do this, and then that will be equal to this part and this part. We'll have to find out the value of that. And area equals base times height by 2. So to find out the base, we'll have to know the difference between the two coordinate points. So then this is negative 4. So we know that the values of y is the same, so then we'll have to know the values of x, the difference between, or sorry, the distance from 4 and negative 4 on a number line. So it's going to be negative 3, sorry, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. It's going to be 8. And so the length of this part will be, the base will be equal to 8. And once again, we just find this out because we know that the y is equal to y. They both are the same value, 5. And x is equal to 4 and negative 4. So then we'll have to know the distance between 4 and negative 4 number line. So since we found out the value of the base, we'll have to know the value of the height. So in this case, we can do this one. So here. So we'll have to do that. We'll have to know that here, since we know the base, we'll have to know that the value of this part right here. And so since we have two coordinates here, we can do that from the distance from 0 to 4 is equal to 4. The distance from 1 to 5 is also equal to 4. And so the height will be equal to 4. So the area is equal to the base, which is equal to 8, times the height, which is equal to 4, divided by 2. So the area will be equal to 32 by 2, which is equal to 16. And so that's how we got our answer E, 16. Once again, if you would like to just double check, you can use the shoelace theorem. This is called the shoelace theorem right here. You can use this formula to find out the value of the total area. Yeah. Problem number 22. A store increased the original price of a shirt by a certain percent and then decreased the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? So it was increased by the same amount and decreased by the same amount. So we know that 1 plus x, so 1 plus some amount, times 1 minus x is equal to 0.84. 84% is equal to 0.84 as a decimal. And so we can do 1 plus x minus x is still equal to 0. So 1 plus x squared equals 0.84. And so if we subtract 1, we're gonna get x squared is equal to 0.16. And so also we'll have to do the absolute sign here. So it'll actually be equal to negative 0.16, but since since the x squared cannot be equal to a negative number, because negative times negative is equal to positive, and positive times positive is still equal to positive, we'll have to add the absolute value sign here. So we'll get x squared is equal to 0.16. And so if we would solve that, well, x is equal to the square root of 0.16. And so x equals 0.4. So 0.4 converting into a percentage form is equal to 40%. And that's how we got our answer choice E. That's how much percent they increased it by, and that's the same percent that they decreased by. And that's how we got our answer choice E. Problem number 23. After Euclid's high school last basketball game, it was determined that 1/4 of the team's points were scored by Alexa, and 2/7 of them were scored by Brittany. Chelsea scored 15 points. None of the other 17 members scored more than 2 points. What was the total number of points scored by the other 7 teams? So none of the other 7 teammates scored more than 2 points. So then suppose that the 7 teammates can be equal to, we'll do like x. So x has to be greater than or equal to 0 since they cannot score a negative number, and less than or equal to 14. We got 14 because 7 times 2, and none of them scored more than 14. So it can be equal to 14. And so if we would represent this on a number line, we'll be getting, so this point will be equal to 0, this point will be equal to 0, and this point will be equal to 14. And so x can be anywhere between these two numbers, and this point will be shaded in so that because this point will be counted 0, because it can be greater than equal to 0 and less than or equal to 14. And so x can be anywhere between these 2 points here. And yeah, we can solve this. So t is the total number of points that they scored. So t is equal to t by 4, 194, and then plus 2t by 7 plus 15 because Chelsea, and plus x. X once again is the total number of points the other 7 teammates scored. Suppose that t is the least common multiple of 4 and 7. So t can be equal to 28. So suppose that t is equal to 28. So if t is equal to 28, then that means that t is equal to, well, what's t by 4? So 28 by 4, which is equal to 7. 7 plus 2t by 7, so 2 times t, so 20. So if we do that, then we're going to get 56 by 7, which is equal to 8 plus 15 plus x, so plus x. And so we'll be getting 30 already. 30 plus x, we don't know the value of x. So 30 plus x is already greater than 28. Since x cannot be a negative number, x has to be less than No, sorry. Yeah, less than 14, but greater than or equal to 0. So then this cannot work. So t cannot be equal to 28. Well, what's 28 times 2? 28 times 2 is equal to 56. So can t be equal to 56? Well, we'll have to solve this. So t can be equal to 56 question mark. So then if t is equal to 56, so then t by 4 is equal to 14. 14 plus 2t by 7 is equal to 16 plus 15 because of Chelsea here. I'm just substituting the value of t right here. Plus x is equal to 56. So 45 plus x is equal to 56, so 45 plus x, and we just need to find the value of x. So since we know that the 45 plus x is equal to 56, we'll have to subtract 45 on both sides. We're going to be getting x equals 11. And that's the total number of points the other 7 teammates scored. And that's how we got our answer choice being 7. Does anyone have any questions on this problem? Okay, if no one has
Why
any questions,
why 28?
20, it's because it's 20 and because it's the least, because it's the least common multiple of 4 and 7. And we want it to be the least common multiple of 4 and 7 because they told us that because they told us that 1/4 of them were scored by Alexa and 2/7 were scored by Brittany. And so the least common multiple, because we want the denominators to be the same. And so t is equal to 28 because once again, it's the least common multiple of 4 and 7. Problem number 24. In triangle ABC, point D divides side AC so that AD is equal to DC in the ratio form 1 to 2. Let E be the midpoint of BD and let F be the midpoint of the intersection of BD. And line AE. Given that the area of ABC is equal to 360 degrees, what is the area of triangle EDF? So then, once again, let me read this problem, but I'll say it in a slower, I'll say it slower so that and explain that each part. So point D here divides AC, this whole AC divides AD. So D divides AC so that AD is equal to 1 and DC is equal to 2. And so this whole thing will be equal to 3, right? Because 1 plus 2 is equal to 3. Let E be the midpoint of BD. So midpoint meaning that so ED and BD are both the same length. So I'll be drawing a congruency mark right here. And point F be the intersection of the line of BC and AE. So this is just the intersection where AE meets BC. So right there, point. So what is the area of triangle EBF? What is the area of this triangle right there? What is the area of this triangle? So to find out the area of this triangle, well, we'll have to, since we know that the total area of ABC is equal to 360 degrees, what is the area of EBF? So what is the area of this? So we'll have to do 360 degrees divided by 2 plus 1, which is equal to 3. So 360 degrees divided by 3, which is equal to 120. So that means that this triangle right here, since it's 1, is equal to 120 degrees. And this triangle right over here is equal to 240 degrees. But one thing that I would like to say before this is that we know that BE and ED are both equal, since I showed the congruency marks, marking that they both are equal. And so then that means that the areas must be equal as well. And so we'll have to do 120 divided by 2. So then that will mean that this triangle right here will be equal to 60, and this triangle right here will also be equal to 60. So And we also know that this one right here is equal to 240. 240. 240. So, I'll change the color to, we'll do green. So, I'll just connect this dot right here, to split this point into two equal triangles. So, this triangle can be equal to maybe G. This point right here can be equal to G. Or I'll just make it, yeah, I'll make it G. Okay? So that point right there is equal to G. And so this point right here splits the two triangles in half. And before we actually solve this, let me solve the area of this one. So let me explain something. So this is two parallel lines. So assume that these two are parallel lines. And then there's a transversal line that splits those two lines. So that means that this angle right here and this angle right here are vertical angles, meaning that they both have the same side, both have the same angle, and this angle have the same angle as well. And now we also know that this angle right here and this angle right here have both the same side length, or not the side length, I mean the angle, and this angle have the both angle. They both have the equal angle. This is called vertical angle theorem, and yeah, there's also something called the exterior angle theorem, which means that the alternate, so meaning that the alternate, so this side is alternate to this side. The alternate exterior meaning that the line outside, alternate exterior angles are equal. Alternate interior angles are also equal. And the same side exterior and the same side interior are supplementary, meaning that they both equal 180 degrees. So yeah, those are just some theorems of this, and this will help us solve this. So that means that, see these two angles right here? This angle and this angle are equal because these two are vertical angles. This angle and this angle are equal, but we don't need that for now. We just need to know the angle of this one. So that means that this side length, we need to prove the congruency of these two triangles. So we know that here, this line is the same for both of these. So they both share two side lengths. So they both share one angle. They both share two side lengths. So they both share the same, they both share the side lengths, and they both also share the angle, which proves that the angles the triangles are equal. This is like one, so there's the side, angle, side. So side, angle, side, which is one way to prove a triangle's congruency. So there's also side, angle, side. So if all of the sides are equal, there's also many others. Like maybe we can do angle, side if they both share like two of the same angles or something. So there can be something like that too. But all we care is about the side, angle, side for now. So that means that these two angles are the same. And once again, remember how this total one is 60? Remember that? 60 right there. So that means that this side will be equal to 30. This side will also be equal to 30 because this line right here splits the triangle in half. And so 30 right here and 30 right there. And so so we know that EGD is equal to BEF. So if this one is equal to 30, it means that this one is also equal to 30. And that's how we got our answer EBF. That's how we got our answer choice B. Does anyone have any questions about this? About maybe like the angles right here?
But like, how is the EBF 30?
EBF?
Yeah.
Okay, so EBF is 30 because did you understand how Did you understand how ADE is 60? You can unmute.
Yeah.
Okay, so if you understand why this is 60, so we got first of all we got 120 right here because we would have to do 360 divided by 3, which is equal to 120. Since we know that this side is 1 and this side is 2, just following the ratio. So then we know that BE is equal to ED since they told us that. Since they told us that E is sorry, where, yeah. Since they told us that E is the midpoint of BD. Okay? They told us that in the question right there, E is the midpoint of BD. And so now we know that BE and ED are both equal side length. So if they both are the equal side length, that means that these two triangles have the equal area. Since they both like share the equal angle, and you can prove the triangle congruency, like this angle right here must share that angle. It's equal to like, and so yeah, so that's how we got 60 and 60 right here. So AED is equal to 60. And so we split the triangle in half because we want to find out EBF. So we want to find out EBF. So we split this triangle in half. And so when we split this in half, we just proved why why G. I just named this point G, but you can name it anything. Like suppose that can be uh we'll just make it G, but that point can be anything. You can name it like X, Y, Z, anything. But I just named it G because it goes by alphabetical order. But yeah, you can name anything. So EGD is equal to half of 60. So 1 by 2 of 60. So 1 by 2 times 60. So half of 60. So 1 by 2 times 60 over 1 is equal to 30. So we got this point 30. And so we found out that this side is 30 and this half is also 30. And now we started proving why these two triangles are congruent. And congruent means like equal. So then we found out that this side is so we found out I just showed you like how the vertical angles are always equal to each other based on the red and pink marks right there. So then this is an angle. They both share an equal side length. So AE is like both the equal side that they both share. And then BD is also one side that they share. So then they share a side. This is one side that they share, AE. They share an angle, which is the vertical angle, and then they also share the side BD. And so proving that those two triangles are congruent, they're both are congruent. That means that they both have equal area. So 30 has to be equal to 30 since EGD is equal to BEF. And that's how we got our answer 30. Did this answer your question? Do you have any other question?
No.
Okay.
But it answered my question.
Okay. So problem number 25. Alice has 24 apples. In how many ways can she share them with Becky and Chris so that each of the three people have at least 2 apples? So, total they have 24 apples. And in how many ways can she share them with 2 other people? So then A, B, C. And they want to make sure that they each have 3, so they have so 3 people have at least 2 apples. So then if they want each of the 3 people to have 2 apples, so 2, 2, 2, then we'll have to do 3 times 2, which will be equal to 6. And so the total number of apples, sorry, that's 3 times 2. And so the total number of apples is 24. And they told us that in the problem. So then 24 minus the apples that are already taken is equal to 18. And so suppose that we need a value for apples. So suppose that Suppose that we can do x. X equals the number of apples. So x has to be greater than 0. It cannot be 0 because there cannot be zero possible ways that are possible. So x has to be greater than 0, but are less than or equal to 18. So, and there has to be 18 different numbers in this possibility. So then if we do 18 plus 17, we have to add these because we need to know like the different possibilities to do this. 18 plus 17 plus 16 all the way until 0. Well, first of all, we can't do 0. We can't do 0 because x has to be greater than 0. But x has to be less or equal to 18. Well, in this case, we would have to add 1 here because we cannot do 0 and there has to be 18 different possibilities. And we can definitely not do 0 because there cannot be 0 different ways. We already know one possible way, 2, 2, 2. So we will have to do 19 plus 18 plus 17 all the way until all the way until 1. And if we want to add all of these up together, we will be getting 190. And that's how we got our answer choice C. There's also a different way to do this. It's called bars and stars, but that's a bit harder to do. And this is like, if you write this equation here, and if you need to add 1 here, to this one, that would make sense too because once again, there's no 0 possibilities. I think the hardest part of this problem would probably be writing this equation, and then the rest of it is pretty much easier. But bars and stars, you'll have to do, I think, a little bit more, and you have to like write like the possibility. So then I think that this is a better way to do this, but you can also use that. It's called bars and stars. So yeah. Does anyone have any questions about any of the problems that we talked about so far?